Hello everyone, I'm Sebastian Y, and this is Managerial Economics. In this video, we're going to talk about the principal-agent problem. In the last video, we covered how to do the consumer's problem, which is a form of utility maximization. We can use what we learned there to look at a different situation where people also maximize utility. The principal-agent problem is a utility maximization problem of particular interest to managers. Within a firm, the goals of an individual worker, who we call the agent, and the firm's owner, which we call the principal, might not be perfectly aligned. The agent is trying to maximize their utility, and the principal is trying to maximize the profit of the firm. The principal-agent problem is the problem of how the firm can get the agent to put forth their best effort towards the goals of the firm. We'll start by thinking about the incentives for a manager. A manager is a person like anyone else and has preferences over bundles. One thing in that manager's bundle is their income. Manager likes income because they can then use it to get other things, which we talked about in the last video. But income is not the only thing that people care about. Working to the firm's benefit is costly to our manager because they need to give up some leisure time in order to do so. Specifically, we're talking about leisure on the job, which we call shirking. Shirking can be anything that involves not doing work at work, such as long coffee breaks, chatting with colleagues, or just watching a cat video at their computer. We can use a utility function to describe the manager's preferences over income and shirking, just like we did a consumer's preferences over a bundle of good X and good Y. The manager's goal is to maximize their utility. The owner's goal is to maximize the profit of the firm. In order to do that, they need the manager to not shirk and instead work hard towards the goals of the firm. The tools available to the owner are different compensation schemes, which we will talk about. The simplest possible compensation is a fixed salary. A fixed salary will give the manager the same amount of pay no matter what happens. For example, let's suppose that our manager gets a fixed salary of $50,000 a year. Let's draw a graph of this. Just like before, we have a choice between two things. Instead of good X and good Y, they're going to be shirking and income. For consistency, I'm always going to put shirking on the horizontal axis and income on the vertical axis. Suppose that our manager works for 8 hours at their job. This means they could spend up to 8 hours shirking. Shirking of 0 means they're working hard all day. Shirking of 8 hours means they're not doing any work. On the income side, they are getting a fixed salary of $50,000. With a fixed salary, we have a budget set, which is a rectangle. This looks a little bit different than what we were used to with our triangular-shaped budget sets from before. The reason for this is that there's no trade-off between shirking and income. No matter what happens, our manager can get their full income of $50,000. That's not connected in any way to an amount of shirking. What this means is that our manager can get the best possible point, which is shirking all day long, still getting their full income. And this is definitely the choice they're going to make. If we start to draw some indifference curves, we know that they're going to take their whole income, so the point we're thinking about is this one right here. They could shirk about half the time, it looks like, and get $50,000, but they can do better than that. We can move this direction. We can keep drawing more indifference curves, and we can still see there's points along the budget set that are still in there until we get to this point right here. We can see that the utility maximizing choice is shirking all day. What this tells us is that a fixed salary is not going to be a very effective way to get effort out of our employee. So, if the fixed salary is not going to work, what's the alternative? The alternative is what we call an incentive contract. Incentive contracts is a very broad term encompassing all kinds of different compensation schemes where compensation is directly tied in some way to the company's profit. An example of this would be giving the manager stock options. For example, we could give the manager a call option. A call gives the holder the option to buy a stock at a locked-in price called the strike price at a predetermined future date. If the price of the stock goes above the strike price, then the manager can exercise the option and buy the stock at the lower strike price and then make a profit. The idea behind this is that it encourages the manager to put forward effort, which may result in the price of the stock rising. We could also use a direct profit-sharing scheme. For example, the manager could earn 10% of the firm's total profit. The manager still values shirking, and so this does not mean they're going to work hard all day, but it is going to be an improvement because the incentives now are more aligned with the owner of the firm. Let's do an example of profit sharing. Suppose our manager has a utility function u of sm equals s to the 1/3 m to the 2/3. This is deliberately very similar to our example utility function from before, except that we have shirking and income instead of good x and good y, but it will work the same. We're also going to assume our manager works an 8-hour day, just like before. Suppose that for every hour of effort that is not shirking, the manager will earn a profit of $120,000 for the company, and based on the profit sharing, they will get 10% of that. This means that our manager's total income will be 8 minus S, that's the total hours spent not shirking, so the 8-hour day minus the hours shirking, times the $120,000 they earn for the company, but they get 10% of that, so we'll multiply that by 0.1. We multiply this whole thing out, that's going to give us 96,000 minus 12,000 S. This is our manager's budget line. The way that you can think about this is that the price of an hour of shirking is 12,000. We're going to solve for the equilibrium just like we did before, by setting the MRS equal to the price ratio and solving that as a system of equations with our budget line. I'm going to move quickly through the MRS because we already did this in a previous video. First, we need to calculate the marginal utilities. So the marginal utility of shirking is going to be 1/3 s to the negative 2/3 m to the 2/3. Marginal utility of m is going to be 2/3 s to the 1/3 m to the negative 1/3. And then to get the marginal rate of substitution of shirking for income, we're going to take the ratio of those, 1/3 s to the negative 2/3 m to the 2/3, divide that by 2/3 s to the 1/3 m to the negative 1/3, and then simplify that down, which comes out to m over 2s. As I mentioned in the last video, I showed how to do this step by step in the video on preferences and utility, so I won't get into detail right now. We now need to set this MRS equal to the price ratio. So we need to have m over 2s equals the price of shirking divided by the price of income. So what are those? Well, the way we can think about this is that the price of income is just 1. The price of $1 is $1. But the price of shirking is the 12,000 that they're giving up by not working hard. Alternatively, remember that the price ratio is the absolute value of the slope of the budget line, which we also know is 12,000. So what we have is m over 2s equals 12,000 over 1. Now we have everything we need to solve for the equilibrium. We have our MRS equals the price ratio, and our second equation, which is just the budget line, which I'm going to rewrite here, m equals 96,000 minus 12,000 s. We have two equations and two unknowns. We'll go ahead and solve. As always, you can go about this however you want. I am going to show one way. I'm going to take equation 1 and I'm going to solve it for m. So I'm going to take this equation and I'm going to multiply both sides by 2s to give me m equals 2s times 12,000, which is going to be 24,000 s. I'm now going to take 24,000 s and I'm going to plug it into our second equation right here where we see the m. So we have 24,000 s equals 96,000 minus 12,000 s. Add the 12,000 S to both sides. That's going to give me 36,000 S equals 96,000. We can actually just cancel out all of these zeros if we want, basically just dividing both sides by 1,000. So then we can just divide both sides by 36 and get S equals 96 over 36, which is 8/3. All we need to do to finish this off is just plug this back in right here, where we had M equals 24,000 S. So we have M equals 24,000 times 8/3, which is 64,000. This tells us our manager is going to shirk 8/3 hours a day. If we think about this a little bit, that equates to 2 hours and 40 minutes of shirking per day, and then they're going to make their yearly income of $64,000. Let's show this thing on a graph. We'll mark out S and M for our axes. To graph the budget line, we'll find the intercepts. As before, 8 hours is the maximum amount of shirking. That would be shirking all day, every day. The total amount of income possible would be if they were to work hard for 8 hours, and that would make them 12,000, which would come out to 96,000. So we'll graph that. Use a red line to draw in our budget line. Note that there is now a trade-off between shirking and income, unlike with the fixed salary, which gives us our triangular-shaped budget set just like we had before in consumer choice problems. We know that in the equilibrium choice, we have 8/3 as our equilibrium amount of shirking, so we can take that about here, and that's going to correspond with an income of 64,000. We can then draw in an indifference curve that is tangent at that point. Setting things up like this allows us to solve a problem in a completely different context from the consumer problem, but using the exact same techniques. One question that often comes up at this point is about the assumption that people will not work at all given a fixed salary. Of course, we know in real life many people do have a fixed salary and they don't shirk all day. It's important to remember that what we are doing is an economic model, where things are simplified down to a small number of variables so that the math is possible. They don't necessarily reflect reality 100%, but they allow us to get a sense for how people would think. In real life, of course, if you were to shirk all day, you probably wouldn't last very long in the job. External incentives also exist. For example, working hard can build up the manager's reputation, which they could then use to switch jobs to something where they make more money. Another possibility is that a shirking manager could lead to a firm that does not perform very well, which could then be bought out by someone else, and our shirking manager has a high risk of then being fired by the new owners, and they don't want that. The last thing that we're going to do in this set of videos is talk about some worker incentives. The relationship between the owner of the firm and the manager is just one part of the structure of a firm. Below the manager, we have a number of workers who have a similar relationship to the manager as the manager does to the owner. If the manager has an incentive contract whose income is based on the firm's profit, it's also in their interest to motivate the workers under them to also work hard towards the firm's goals. So our manager now needs to figure out a way to motivate the workers to not shirk. One way to do this is through monitoring. Time clocks are the simplest form of monitoring, which at least ensure that employees show up, but they don't necessarily guarantee that the workers who are there are not shirking. Spot checks can be an effective form of monitoring, but it has to be done randomly. If workers know when the boss is coming through, then they know exactly when they can shirk and when they can't shirk. If monitoring is random, then workers will have to work hard all the time to make sure they don't get caught. This, of course, has to come with some kind of penalty if people are caught shirking, which is why monitoring can be bad for morale, and if there are a large number of workers, it can become impractical. As such, some kind of incentive contract can be an attractive alternative to this. Revenue sharing is a form of incentive contract where the worker's pay is directly tied to the revenues of the firm. This can be effective when worker productivity is mostly tied to revenue rather than cost. Examples of this include commissions for salespeople and tips for waitstaff. One problem with revenue sharing is that it does not incentivize the workers to keep costs down. For example, a waiter who works for tips might now be encouraged to offer free drinks in order to increase their tips, but this is going to start to add up as a cost for the firm. In general, this can be a bad thing because revenue sharing encourages workers to just keep selling regardless of cost. Another form of worker incentive contract is a piece rate. With a piece rate, workers are paid a fixed amount for each unit of output that they produce. The main problem with this is that it is tied only to production and not sales. Piece rates can incentivize quantity over quality. If the quality of product starts to slip, then they're not going to sell, and that's not going to be a good thing for the firm. Both revenue sharing and piece rates are alternatives to having a fixed hourly wage for workers, which would have the same effect as the fixed salary for the managers of not incentivizing hard work. Let's look at an example of a piece rate. Suppose we have a worker who works an 8-hour shift in a factory making widgets. She can build 3 widgets an hour and gets paid a piece rate of $5 per widget. We're going to continue with the utility function u of sm equals s to the 1/3 m to the 2/3. We now want to write out our budget line. Total income is going to be, again, 8 minus s, so the hours spent working. She can make 3 widgets an hour by working, and for each widget makes $5 of income. Let's multiply this whole thing out. What we get is 120 minus 15s. To figure out the equilibrium, we need to again solve the system of equations that we did before, but with our new budget line. I won't go through the math on the MRS again. The MRS, since we haven't changed the utility function, is still m over 2s. But that's now going to be set equal to the new price ratio. Since the cost of shirking is now $15 an hour, we have to set this equal to 15 over 1 instead of the 12,000 over 1 from the last example. And solve this as a system of equations. We have equation number 1 and we have equation number 2. We go about this the exact same way. Again, I'm going to multiply both sides of equation 1 by 2s, and that's going to give me m equals 30s, which I'm then going to plug in to equation number 2 right there. So we're going to get 30s equals 120 minus 15s. Add 15s to both sides. That will be 45s equals 120. Divide both sides by 45. When we do that, that also comes out to 8/3. All that's left is to plug this back into this equation right here. M equals 30 times 8/3, which is going to be 80. So this tells us that our worker is going to shirk for, again, 2 hours and 40 minutes and make an income of $80 a day. We can also sketch up a graph of this. We again have a maximum amount of shirking of 8. This time the maximum amount of income is going to be 8 hours times 3 widgets times $5, which is 120. Draw in our budget line. Mark out our equilibrium, which is 80 and 8/3. And then sketch an indifference curve. And that's our graph. The last thing I wanted to mention is that we can also combine these different compensation schemes. For example, we could give a worker an hourly wage and then have them work for a piece rate on top of that. Or with the manager, we could give a fixed yearly salary and then do some profit sharing on top of that. As an example, let's consider our manager again and give them a $20,000 fixed yearly salary and then do the profit sharing on top of that. The maximum possible amount of shirking is still 8 hours a day. If they shirk all 8 hours, they can still get that initial 20,000, but on top of that, now we have profit sharing kicking in. So if they shirk a little bit less, then they're going to get more income, and we now have a triangle on top of that. This gives us a kinked budget line with a trapezoid-shaped budget set. Maximizing utility, they could end up somewhere out here, but with different preferences, they might also end up still shirking all 8 hours. And that is it for the material on individual behavior. We've covered a lot of ground here with a lot of math, so make sure that you are carefully going through each step. And if you have any questions, feel free to let me know. Thanks for watching.